Hello everyone, welcome to Math Edu. Today we study the exercise number 1.2, the questions on differentiation. Then here we have to find the derivative of the function, that is the derivative of the inverse function. Then here we are given the function y is equal to f of x using the derivative of the inverse function x is equal to f inverse of y. In the following example, we have to find the derivative. That is how to find the derivative of inverse function. For that, just we see the theorem first and then we start the example. Derivative of inverse function is that suppose if y is equal to f of x is a differentiable function of x on an interval I, and y is 1 function, and if dy by dx, that is derivative of y with respect to x, is not equal to 0 on the same interval. Also, if f inverse of y is a differentiable on this interval f of y, then the derivative of f inverse of y is equal to 1 upon f dash of x, or this derivative of x with respect to y is 1 upon dy by dx. That means here, in order to find this derivative dy by dx, that is we are given in the example, we have given the value of y in terms of x, that is y is equal to f of x. That is the finally we have to determine this dy by dx. But for this question here, first y is equal to f of x is given. From this y is equal to f of x, we have to express this x in terms of y. Means x is equal to f inverse of y. That is, if we multiply whole this equation by f inverse, then f into f inverse, we know that it is identity. If we multiply f inverse, then we get here f inverse of y is equal to f inverse f of x, and this f inverse into f inverse is identity, and we remain is here f inverse of y. Means f inverse of y is equal to x. Or directly either you can transfer this f of y, f of x is equal to y, that is if you transfer this f to the right hand, then it is inverse. Means x is equal to f inverse of y. Means we have to express this x in terms of y, and then we differentiate this x with respect to y. Means we get dx upon dy value. After getting this dx upon dy value, which is the same thing as dy by dx is equal to 1 upon the reciprocal of dx upon dy. Dx upon dy. Okay, means dy by dx. How to obtain this dy by dx in this type of an example? We have first given this value of y in terms of x. From that, express this x in terms of y, and then differentiate this x with respect to y, and then we get dx upon dy value. From this dx upon dy value, how to get dy by dx? If we take this reciprocal of whatever we get the value of dx upon dy, we get dy by dx. Means for example, suppose if I given the value of y as in terms of x, means suppose x square. Okay, y is equal to x square. Then we have to express this x in terms of y. Means what we get, x square is equal to y. X square is equal to y, means x is equal to root of y. And then we differentiate this x with respect to y, means dx upon dy. Then what we get, root y derivative 1 upon 2 into root of y. And then again we express this y in terms of x. In the given example, we have provided y in terms of x, means like this, y is equal to f of x, and then we have to express this x is equal to f inverse of y, means we have to express this value of x in terms of y. Then in order to express this in terms of y, we take square on both sides. Okay, squaring on both the sides. Then after squaring, we get y square is equal to x, means we have expressed this x in terms of y. Okay, y is equal to x is equal to y square. Then differentiate with respect to y. Why we differentiate with respect to y? Differentiate this x with respect to y because x is a function of y. If y is a function of x, then we differentiate this y with respect to x. Okay, means we get derivative of this x square. But here x is a function of y, then differentiate this x with respect to y, means dx upon dy is equal to dy of what is x? Y square. Then this dx upon dy is equal to derivative of y square with respect to y is 2y. Means dx upon dy we get 2y. But we have to find this dy by dx. Then what is dy by dx? That is dy by dx is nothing but 1 upon dx upon dy. That is the reciprocal of this 1 upon dx upon dy. When we take reciprocal, it becomes dy by dx. Okay, that is, we know that 1 upon 2. Then this goes to the numerator. Then same thing, this 1 upon dx upon y means dy by dx. Then this 1 upon dx upon dy is here 2y, means here dy by dx is equal to get 1 upon 2y. But what is y? This value of y is nothing but root x, means again we substitute this as in the given form, that is 2 into root x. Then what we get? Derivative of root x means 1 upon 2 into root x. All this example in the question number 1 we solve like this, means first value of y expressed, we are given value of y in terms of x, we express this x in terms of y, and then we differentiate, we get dx upon dy. So whatever we get the value of dx upon dy, take its reciprocal, we get dy by dx. Then all the example in question number 1 we solve like this. Then in the second one example, here also y provided y is equal to, then here also we have to express this x in terms of y. But when we get x is equal to, for that we have to remove the square root signs. Okay, that is something here. We express x in terms of y, for that we remove this square root sign. Same thing here, square root of square root term is there. Then for that, in order to express this x in terms of y, we take squaring on both side first. Okay, then when we take squaring on both side, then this y square is equal to, this first square root is get removed, remain is 2 minus root x. But here again is 1 square root term, but before this we transfer this 2 to the left hand, then we get y square minus 10 2 is equal to minus root x, and then again squaring on both sides, we get y square minus 2 square is equal to x, is equal to y square minus 2 square. Then in order to find derivative, then differentiate with respect to y, then dx upon dy is equal to this derivative of dx upon dy, this derivative of y square minus 2 square, that is dx upon dy is equal to this square x raised to n form, when that x raised to n into x raised to n minus 1 into derivative inside term. Same thing here, that is 2 into y square minus 2 into derivative inside term, this dy of y square minus 2. Then this has 2 into y square minus 2 into this derivative as 2y, means what we get finally 4y into y square minus 2. This is the value of dx upon dy. But what we want? Dy by dx is equal to 1 upon dx upon dy, means 1 upon 4y into y square minus 2. Then we substitute value of y means root of 2 minus root x, and y square means 2 minus root x. Okay, then this dy by dx, we get this dy by dx is equal to 1 upon 4 into y means this value root of this 2 minus root x into this y square minus 2, y square means 2 minus root x. Okay, y square minus 2, that is 2 minus root x minus 2. This has y square minus 2. Then this plus 2 minus 2 get cancelled. Then this dy by dx is equal to this 1 upon 4 into root of 2 minus root x into this 1 upon minus root x. Then this minus root x we take is outside minus sign. Then dy by dx is equal to, we get minus time 1 upon 4 into root x into root of 2 minus root x, which is the value of dy by dx. We are given y is equal to cube root of x minus 2. Then in order to express this first in terms of x in terms of y, we have to remove this cube root sign. That is, we know that if y is equal to cube root of x, then we take, means cube root means x raised to the power 1/3, and if we take cube on both sides, then we get y cube is equal to x. Then something also here, cube root is there, means y is equal to this x minus 2 raised to power is 1/3. Then in order to remove this cube root, taking cube on both sides, what we get? Y cube is equal to, here remain is x minus 2 raised to 3 and raised to this 1/3, that is taking cube on both sides, this and this get cancelled, and remain is y cube is equal to only x minus 2. Then after that we express x in terms of y. Then what we get, this y cube is equal to x minus 2, transfer this minus 2 to the left hand, means y cube plus 2 is equal to x is remain, means we get x is equal to y cube plus 2, means x in terms of y. Then differentiate this with respect to y, differentiate with respect to y. Then when we differentiate this with respect to y, means dx upon dy is equal to derivative of y cube is 3y square and this constant derivative is 0. But what we want, dy by dx. Then dy by dx is 1 upon dx upon dy. Means what? That is 1 upon dx upon dy is 3y square, that is reciprocal of this. And then substitute value of y square again, means dy by dx is equal to, we get 1 upon 3 into, what is y square? Y means this one, then y means this one, y square means rest to power is 2. Okay, rest to power is 2, means what we get, y is equal to this 3 into the cube root of this y is x minus 2, rest to power is 2. Okay, this has value of y, and rest to power 2 means y square into 3 times cube root of x minus 2 square is the value of dy by. And here this x must be strictly greater than 2. Okay, then for the next example, y is equal to, again it is expressed in terms of x, then we want x in terms of y. Then in order to remove this logarithmic term, that is a log to the base e is there, then when we take exponential on this side, here we get 2x minus 1. Okay, means we get e raised to the power y is equal to this 2x minus 1. Okay, that is we know the properties of logarithm, log to the base e is there, then we take exponential, means we get e raised to y is equal to 2x minus 1. Then here 2x minus e raised to y is equal to 2x minus 1. Then express x in terms of y, transfer this minus 1 to left hand, e raised to y plus 1 is equal to 2x, means what is x is equal to e raised to y plus 1 divided by 2. Then x is in terms of y, then differentiate with respect to y. Then this 1 upon 2 is a constant, take it outside, then dx upon dy is equal to, we take constant term outside, and derivative of remaining with respect to y is e raised to y plus 1, means this 1 up constant, exponential derivative, you know that it is exponential, and this constant one derivative is 0, means what we get, e raised to y divided by 2, means dx upon dy is dx upon dy is equal to get e raised to y divided by 2. Okay, we want the value dy by dx, that is nothing but the reciprocal of this dx upon dy, means what, 1 upon e raised to y divided by 2, means 1 upon e raised to y divided by 2, it becomes 2 upon e raised to y, means dy by dx is equal to 2 upon e raised to y term. Then what is e raised to y? The value of e raised to y we have find here in terms of x, means 2x minus 1. Then we substitute this value, e raised to y as this 2 divided by 2x minus 1, means dy by dx is 2 divided 2x minus 1 is the value of derivative. Then for the next one example, here also first express x in terms of y, that is for each and every example of question 1 we have to express in terms of y. Then what we get from the first one, that is y minus 3 is equal to 2x, then x is equal to, dividing this 2, y minus 3 divided by 2. Then differentiate with respect to y, dx upon dy, here again 1/3 is constant, take it outside, into dy of this numerator y minus 3, means dx upon dy is equal to this 1/2 constant, y with respect to y is 1 and constant derivative is 0, means what is remain 1/2, that is dx upon dy is 1/2. Then what we want, dy by dx, that is 1 upon dx upon dy, means what, 1 upon dx upon dy is 1/2, means 1 upon 2, then it is 2. Okay, therefore what we get, dy by dx is equal to 2. Then the next one, y is equal to e raised to x minus 3 is given. Then we have to first express x in terms of y. Then for that, what we do? Transfer this 3 to left hand. Y plus 3 is equal to e raised to x. Then we want x is equal to taking log on both sides, that is logarithmic of base e. Then log of y plus 3 is equal to get x, because when we take log on both sides, already log base is e to the base, this is as e to the base is 1, then the remaining is only x. Okay, then log of this y plus 3 is equal to x, differentiate with respect to y. Okay, dx upon dy is equal to derivative of dy of log of y plus 3. Then log derivative, you know that it is reciprocal, 1 upon y plus 3 into derivative of this inside term, that is d dy of y plus 3. Okay, then dx upon dy is equal to get 1 upon y plus 3, and this derivative of y with respect to y is 1 and constant derivative is 0, means dx upon dy is 1 upon y plus 3. Then from that, what is dy by dx? That is 1 upon dx upon dy, that is 1 upon y plus 3. Then what to get? 1 upon y plus 3, that is y plus 3, means dy by dx is y plus 3. Okay, therefore dy by dx is y plus 3. Then we substitute y in terms of x, then dy by dx, what is y? Y is our e raised to x minus 3. Then substitute this e raised to x minus 3 and this plus 3 get cancelled, minus plus, the remaining is dy by dx is equal to e raised to x, which is the value of derivative. Then here next one is also same. In order to express x in terms of y, here exponential, then taking log on both side, or when we have to eliminate exponential on one side, we have to take log on other side, or when we have to eliminate log on one side, we have to take exponential on other side. Okay, therefore means same thing, if e raised to x is equal to y, then x is equal to log of y, take log on other side. Or suppose if x is equal to log of y is there, then what to get? Y is equal to, we have to take, in order to eliminate like logarithm, we have to take exponential on other side, means y is equal to e raised to x. Okay, here same thing, log of y is equal to this 2x minus 3. Then in order to get x values, transfer this minus 3 here, that is 2x is equal to log y plus 3. Then what is x? Log y plus 3 divided by 2. Then differentiate with respect to y. Okay, then differentiating with respect to y, but we get this dx upon dy, this again 1/2 constant, take it outside, then into dy of log of y plus 3. This log y is one function and 3 is constant term. Then this dx upon dy is equal to this 1/2 constant, log y derivative is 1 upon y into derivative of y with respect to y is 1, and this constant derivative is 0. Dx upon dy is 1/2 into 1 upon y, that is 1 upon 2y. Then dy by dx is equal to 1 upon dx upon dy, that is 1 upon 2y, that is 2y. Then what is value of y? Is e raised to the power 2x minus 3. Then dy by dx is equal to 2 into y, e raised to 2x minus 3. Next one example, here log to the base 2 is given, here base e is given, y is equal to log to the base e is given. Then we express this 2x minus 1 is equal to e raised to the power y. Okay, here base is e, then what we get? 2x minus 1 is equal to e raised to the power y. But here base is 2, then what we get? Something 2 raised to y is equal to x by 2. Okay, 2 raised to y is equal to x by 2. Then from that, in order to find the x, transfer again this 2, means x is equal to 2 into 2 raised to y is there. Then differentiate with respect to y. Then differentiating with respect to y, dx upon dy. This 2 is constant, derivative of 2 raised to y with respect to y. Then we know that a raised to x derivative is a raised to x into log a. Use the same thing result here for the derivative of 2 raised to y. Means what we get, 2 is constant, 2 raised to y derivative 2 raised to y into log 2. Okay, therefore dx upon dy is this one. Then what is dy by dx? Dy by dx is 1 upon dx upon dy. Okay, that is 1 upon 2 into 2 raised to y into log 2. We substitute this 2 raised to y term. Okay, then 2 raised to y is also in terms of x. We substitute this 2 raised to y, that is 1 upon this 2 raised to y is x by 2 into log 2. Then this 2 and this 2 get cancelled. Then what is remain? Dy by dx as only 1 upon x into log 2, which is the value of derivative.